Okay, how to graph a logarithmic function. So this is kind of tricky. So let's say I'm given this logarithmic function here to graph. And first thing I would write it out with y instead of the function notation. So y equals log base 2 at x. So that way it's easy to convert to an exponent. So if you remember, to convert this to an exponent, 2 is my base. It goes to the y power, and it equals x. So 2 to the y equals x. So now it makes it possible to graph. So here's y, here's x, and so I'm going to put an x here. This is where I'm going to show my work. So this is really 2 to the y. And so in this case, we're going to pick points for y rather than pick points for x. Excuse me. So I'm going to start with negative 2. Well, that would be 2 to the negative 2, which is 1/4. Negative 1 would be 2 to the negative 1, which is 1/2. We'll keep on going down. Well, 0 now, and you could pick decimals too, but let's keep it whole numbers. 2 to the 0, that's 1. And now we're at 1. 2 to the first power is 2. And let's extend the page here a little bit so I can fit the last couple in here. 2 would be 2 to the second power, which is 4. And then finally, let's just stick with 3. 3 would be 2 to the third power, which is 8. Okay. So now we're ready to graph these. Okay, here's the x-axis, and here's the y-axis. I'll stick to the bottom here so we can see most of my chart, my table, my t-chart. And you just plot them. You go right a quarter, down 2. 1, 2. Would be right in this vicinity. Yeah, it's board's a little off. Right a half and down 1 would be right here, approximately. 1, 0. 2, 1. 2 1s right there. 4, 2. Right there. And then 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And you've got a pretty good look at what that logarithmic function is. And so there it is. Okay. Now, it's good to point out that it is also symmetric with the line y equals x. The inverse is symmetric with the line y equals x. So you could flip that across that line and come up with the inverse of the function, which would be y equals 2 to the x power is the inverse. So f inverse of x equals 2 to the x power. So if you wanted to also have the inverse plotted on the same, just flip your y and your x around. So that would be, we'll do that in green, negative 2 and 1/4, negative 1 and a half, 0 and 1, 1 and 2, 2 and 4, and let's see. Oh, 1 and, yeah. Oh, 1 and, yeah, 0 and 1, 1 and 2, 2 and 4, and then 3 and 8. So 1, 2, 3, 1, 2, 3, 4, 5, and I'm out of room here, so we'll swing up. 1, 2, 3, 4, 5, 6, 7, 8. And so there's your function 2 to the x, or the inverse of it. And so you can kind of see how the inverse, the exponential function, is related to the logarithmic function. And that's pretty much how to do it by hand. Okay, so if I wanted to plot that logarithmic function as in GeoGebra and wanted to see it in GeoGebra, I know there's some different things you can use for the log of base 2, but if I were going to do anything, whoops, I would start out with the inverse of the function, which was f at x. We'll call it g at x, not to confuse it with the original function. G at x equals 2 to the x. Let me get rid of that parentheses and plot that, and there it is. So that was the inverse, not our logarithmic function. Then I'd plot the line y equals x for our line of symmetry. Now, let's see, let's click on that and maybe change it to a dotted line. Maybe not. Well, we don't have to. I don't have time in the video to do that. So there's my line of symmetry in the middle, and all you need to do then is reflect an object about a line. So reflect object about a line. So I'll click on my object, click on my line, do that again, and there is your logarithmic function plotted. So, you know, that should help you how you do it in Moodle, or not Moodle, GeoGebra. So, kind of a roundabout way of doing it. I'm sure there's 1,000 other ways to do it, but that's using the inverse of the function is kind of, I don't know, that's kind of cool to me. Well, best of luck on graphing these, and I'll see you next time.